All right, Twitch, BitChute, and YouTube. We decided to put everything together today at the Smash News Network, least busted name in news. So let's blast through today's daily space weather. This is the sun in a portion of the extreme ultraviolet spectrum. This is 131 angstroms. A species of ionized iron. It's a great wavelength to view solar flares. We haven't seen any major solar flares. Pretty low levels of solar activity. Here's the solar magnetogram. This data also from the SDO. It relies on polarized light to determine magnetic field polarity. We've got some new action right here south of sunspot 3045. Right down here you can see some activity happening. That looks like a new sunspot perhaps growing. And indeed I think that one is going to be named today. Let's add 171 angstroms to the colorized magnetogram. There you go. There's another species of ionized iron along with the colorized magnetogram imagery. Radio flux only at 96 solar flux units. We've seen a recent large dip. So there is the 1-year chart. The black line there is the radio flux, the 10.7 centimeter radio flux. The red line is the sunspot number. And you can see how proportional they are to each other. So the solar wind's only down to 335 kilometers a second here, and NOAA is not forecasting any geomagnetic storms or geomagnetic unrest for your holiday weekend. July 4th coming on Monday. We do have a global seismic earthquake drought. So if we look at previous years, for example, there is 2010. There's 2021. You can see how many 7+ magnitude earthquakes occurred then by looking at those red bars. There's 2020. There's 2019. There was a large earthquake drought there between July and November in 2019. 2018 featured an even longer one between March and August. There's the 90-day chart. Remember, folks, earthquake droughts end in large earthquakes. So we have had one decent-sized earthquake here over the past 24. It was a 6.0 at the Philippines. That one came in yesterday at 1840 Universal Time. Again, there's the location of that 6 magnitude quake at the Philippines. Remember, folks, any earthquake could be a foreshock. That 6.0 magnitude quake could be a foreshock. Any earthquake could be a foreshock. Sometimes we do get a little advance warning of oncoming disasters. Besides that, things pretty calm here over the past 24 hours, seismically speaking. Let's take a look at volcanoes next. Chicurachki continues to explode, and that's producing a 10,000-foot plume of volcanic ash, flight level 100. Suwanosejima, unknown volcanic ash cloud from Suwanosejima, but it has exploded. Semeru exploding as well. Flight level 140. It's a 14,000-foot ash plume fertilizing the Isle of East Java, Indonesia. Palawa, I guess it's called. Palawa, off Flores Island, Indonesia, now on the list. Produce a 9,000-foot volcanic ash plume believed to be a false alarm. I don't know how a 9,000-foot plume of volcanic ash or flight level 090 could be a false alarm, but that's what the report states. Nevado del Ruiz exploding, flight level 220 over Colombia from Nevado del Ruiz. It's a 22,000-foot ash plume, 21,000-foot ash plume from Sangay. In Ecuador, 15,000-foot ash plume over Revenador as the country of Ecuador gets fertilized to grow some great coffee, perhaps. Sabancaya also exploding, flight level 230. It's a 23,000-foot volcanic ash plume. Please don't pole vault the caldera. Thanks for tuning into the Smash News Network. These busted name of news. We're going to go on with our space weather content. So let's take a look at some additional emission spectra from the closest star. Here you go. This is 211, 304, and 171 angstroms from the SDO. That's yesterday and today. And welcome to July. It's a new month. We hope it treats you well and that the solar wind be at your back. Now we're going to look at the earthly geospace. This is Earth's magnetic moment from space, and we're seeing quite low magnetohydrodynamic pressure surrounding the planet at the moment. This is the last 4 hours. You can see very calm conditions there. The plasma is just chilling in the earthly geospace. We're going to let that play through. Again, the plasma is just chilling It's basically a state of static equilibrium at the moment. Just a static amount of plasma there. We did see a coronal mass ejection strike yesterday. We'll get to that momentarily. Again, that's the last 4 hours of Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. This is in magnetic flux density, or nanotesla. The last imagery was in magnetic flux density, magnetohydrodynamic pressure, known as nanopascals. So things quite calm on the surface level here as well, as one would expect, without a lot of solar wind input to the earthly geospace. Earth's magnetic moment from the ground. Here's a KP index, which has been only either at 1 or 2 for the last about 36 hours here. Planetary K index is a measurement of global geomagnetism. So here's a little CME strike. This was an interesting one. We saw the solar wind density come up to about 14.5 protons per cubic centimeter, about 18 protons per cubic centimeter, and the solar wind speed dropped. So that's what we would call a dense but slow coronal mass ejection strike. Very minor, didn't really cause even a blip in geomagnetism. Current conditions are, we're seeing a little uptick here. Current conditions are about 5.5 protons per cubic centimeter, around 5 protons per cubic centimeter for the solar wind density, and 338 kilometers per second for the solar wind speed. Pretty uneventful there. GOES magnetometer is looking smooth here following the subsiding of a lengthy coronal hole high-speed stream. You can see all those spiky readings there. That's a bunch of plasma showing up in the Earth geospace. Let's take a look at the heliospheric current sheet. And we can't expect to be in a North Pole current sheet soon because there's a large sunspot in the northern hemisphere. So expect a further delay on the Earth changing current sheets. We are currently in a South Pole oriented current sheet shown here in red. Next, the line of sight field plot. As solar cycle 25 progresses, the solar polar fields reverse. And we're watching that happen. There's the solar magnetogram as well. Solar activity kind of low here at the moment. Excuse me. Next, moving into coronal holes. And here's our coronal hole line of sight plot. You can see some South Pole oriented coronal holes here in the Earth-facing zone. Some North Pole ones rotating in as well on the eastern limb. You can see those showing up there in green. Now let's take a look at it visually in 193 angstroms from the SDO. This species of ionized iron is great at showing coronal holes, and you can see a very well-defined one there in the northern hemisphere. It is a South Pole-oriented coronal hole, as is the one down here. And the North Pole ones on the eastern limb here, they will get more defined as they rotate in. Now let's move to sunspots. Likelihood of solar flares not really all that high. Although this group here is a beta class group. This group up here, still a beta class group, just holding on. We've got a new group to be named down here. So this one's going to be known as 3045. This one's going to be known as probably 3046. And then this will be 3047. So we're going to see an uptick in the sunspot number and the radio flux coming in the next couple of days, most likely. And here's a visualization of that in 1700 angstroms. Another portion of the extreme ultraviolet light spectrum. Let me zoom out so you can see the time and date stamps. That is yesterday and today. So not a ton of sunspots, but things are ramping back up here. By the way, if you'd like to support the channel, become a member of the Smash Team at smashomash.com/SmashTeam. If you're not seeing all of our videos in your feed, on your YouTube subscription, for example, head to smashomash.com/SmashTeam and click posts. You should see all of our major releases there, as well as other various posts. This video was originally streamed live to Twitch thanks to our Twitch followers. Twitch.tv/smashomash. Today's featured product is Mensa, Make Earth Not Suck Again. It's up to you. It's been dethroned as our second bestseller. Do Not Pole Vault the Caldera is now our second bestseller. But in any case, this is a public service message brought to you at massive personal risk and expense by Smash staff and I. And if you're wondering, I wear the products. Here you go. There's a Mensa hat. Make Earth Not Suck Again. Seems like a simple concept. Many of you may agree that the Earth has been sucking over the past 2+ years. So do your part. Help us out. Give Smash staff a raise. We're making Earth not suck again. Press like and subscribe. That'll help to make Earth suck less. Press like, press subscribe, press share, tell your friends and foes about us. We appreciate your support. Visit our homepage for all of our links. Smashomash.com is where that's located, and welcome to the Neo Renaissance. Thanks Smash staff for optimizing the page. You can still support us on Patreon as well. There's a permanent invite link to our Discord chat there. You need an invite link to join a Discord chat, and there is ours. Again, welcome to the Neo Renaissance. As we consider the possibility of the rewriting of things like astrophysics and the physical sciences. So, here is your El Teide, Spain ground-based solar magnetogram. And look for a new sunspot to be named in the southeast. So here's the X-ray flux, and we do have an Earth-directed coronal mass ejection that we're going to cover here in a moment. And solar flaring has been calm over the past 3 days. No spikes in the proton flux, no relativistic particles. And let me bring up some solar flare data here from the SDO. 94 angstroms is a great wavelength to view solar flares. You can see some spectacular activity down here in the southeast. And we'll get to those coronal mass ejections here in a moment. First, a star chart. If you're up before dawn, you may see this lovely planetary pileup. Saturn, Jupiter, Mars, Venus, and Mercury all rising ahead of the Sun. As Mercury and Venus speed away and lap the rest of we planets. So here is the solar system forecast. We hope you enjoyed New Moon. Here's what'll be happening here's what'll be happening in a week. Here's where things will be in a week. And if you're wondering, no, the planets are still not going to kill you. Now we're going to look at some coronagraph data from yesterday and today. Here's yesterday. And there is indeed a halo ejection there. You can see everything lighting up around the coronagraph right there. Not right there. And that appears to be directed at the Earth. So we can expect an impact from that in about 2.5 days. Here's just today, and we're going to show you some more detailed imagery on that coronal mass ejection here. Shout out to Tamitha Scove. We dropped Tamitha a comment yesterday. Maybe she saw something we didn't, but in any case, here's what's going on from the perspective of Stereo A and the Soho Lasco C3. So, if we bring this back a little bit, you can see this CME. Part of this has an Earth-directed component. So there are actually two CMEs happening at once. This little wispy feature you see here, that's actually a separate event. That's a higher speed CME. You're going to see two events happening here on the Soho Lasco C3. You can see that higher speed event expected to miss Earth to the west and north. But part of this other event, the more low speed one, is earthly directed. So right in here, you can see some ejecta. That's 4:09 universal time yesterday morning. There was some missing data when we covered this yesterday, but there is a partial halo ejection there. So we can expect some ejecta to arrive in about 2.5 days. Sometime on July 3rd, we would expect to see that impact. So that's your coronagraph imagery. And we'll close out with some additional moving pictures here. This is your 304 angstroms ionized helium view from the GO 16 SUVI. And that's to last about 2 hours. Things have been pretty calm here over that period. And we'll close out with the house favorite, 171 angstroms. The lovely gold tones of this species of ionized iron and its ultraviolet light emissions. Spectacular imagery there from the SDO. Thank goodness the data is back. And don't go anywhere, folks. The Smash News Network Least Busted Name and News continues on. We are going to do our bonus features segment all in one ongoing stream. So here come bonus features, starting with the total electron content forecast. This is going to show you the most likely places on the planet for GPS errors. And GPS errors here are pretty chill at the moment. We do have some satellite charging hazards we'll get to. But as far as your GPS signal, it's looking pretty good for the past day or two. Your GPS satellite is located about 12,500 miles of altitude, and the total electron content forecast shows you the free electrons in between your satellite and your handset. There's a plasmasphere, there's a Van Allen belt, there's another plasmasphere, then there's the ionosphere below that. And depending on how many electrons are in between your GPS satellite and your handset, you may get a refracted signal. So here are some significant charging hazards here, mainly in the South Indian Ocean, just south of the equator. So satellites in that area expecting some internal charging, the charging of internal circuits due to high energy relativistic electrons. Here's your relativistic electron flux at the F layer. It's the F ionosphere layer being measured by the GOES 16 and 17 using radiography from their geosynchronous orbits. And we are remaining in electron warning levels. It's a minor electron storm at the moment. NOAA expecting this to dip, as you can see here in the forecast. No arguments from me there. It's NOAA's forecast for relativistic electrons. Here's the 1-year chart to put it in context. A little bit off the highs here. And next we'll show the F ionosphere layer, located at 300 kilometers of altitude. Here's one slice of the atmosphere. It's the vibrational frequency of the F ionosphere layer. So there's some shaking going on up there, and it's low frequency anomalies galore. If you're not familiar with looking at this data, don't worry. We will show you the anomalygram. So here's the anomalygram showing anomaly in megahertz from the 30-day median. You can see quite a few low-frequency anomalies here, mainly low-frequency anomalies on a global scale. Lots of red, not a lot of blue. Anomaly from the 30-day median in megahertz. Anyway, there's the latest image, 10 o'clock Universal Time ionogram, 10 o'clock Universal Time anomalygram. Continuing on to a ground-based solar observatory from El Teide, Spain. There's the hydrogen alpha imagery, and you can see quite a lot of dark absorption features here on the solar disk, as well as some bright features overhanging the solar disk. Those prominences are the same thing as these filaments. They are filaments, filaments, filaments. And don't be surprised to see additional coronal mass ejections, folks. Remember, we don't need to see sunspots or solar flares to see CMEs. Next, the latest intensitygram and latest colorized magnetogram. Sunspot 3046 forming down here, or maybe 3047. This should be 3045. This should be 3046. This should be 3047. And is there another sunspot rising here in the southeast? Indeed, I can call that. That is indeed a sunspot. So we're seeing a pretty big uptick here. A lot of sunspots showing up here kind of all at once again. Looks like a solar uptick to me. And let's show some additional data here. We're going to show the 335 angstroms view real quick. The cool, soothing blue tones of 335 angstroms. That's yesterday and today. And some more spectacular imagery there from the SDO. May that solar wind be at your back. Let's move into the realm of meteorology. Yes, we cover weather, not only in space, but also on Earth, because, hey, Earth weather is not quite challenging enough. We needed to do something harder, so we went to space weather. So I just want to do a quick report here on sea surface temperature anomalies. These are the sea surface temperature anomalies of the planet, showing you cold water in blue and hot water in yellow. And things are pretty homogeneous on this side of the planet. If we look at the Americas, you can see some significant cold temperature anomalies there. Cold water anomalies there in the southern Pacific, and lots of hot water in the northern Pacific. And last but not least, we'll show you the Atlantic and Indian Oceans. That's what's going on in terms of anomalously cold water in your oceans. So let's show what we normally show in our meteorology segments here, the jet streams and surface winds. Like stands through the hourglass of time, these are the surface winds of your lives. Some strong lows here off the coast of China. China, the coast of China. The China coast. The coast from China. Here are the jet streams of the eastern world. Clear skies over most of Australia, as the jet stream has increased your pressure. Next, the jet streams of the Americas, and the U.S. jet stream largely staying in the northern part of the country, although a little bit of formation happening here around the Carolinas, a little bit of a convergence happening there. And here are the surface winds of the Americas, surface winds of Africa and Europe, the central world. And shout out to our viewers from this planet and others. Thanks for tuning in. Here are the jet streams. Pretty chaotic jet streams here. Africa seeing no jet stream over the central portion of the country at all. Chaotic jet streams happening there in the northern hemisphere as summer rolls on. So here's your weather.gov map for the U.S. Gale warnings continuing there. Small craft advisories all around Hawaii. Dear Magnum PI, be careful on your surf ski. So there is the U.S. weather.gov map. If your county's lit, click your county. Some small craft advisories there along the northeast coast of the U.S. as well. Here's your lightning mapper. It's the NASA GOES lightning mapper. Lots of lightning here over the country and Mexico. Huge swaths of lightning there happening. Continuing on to our real-time lightning map. And since we are streaming live, let's shout out some terrestrial lightning. We've got some in eastern Nebraska. Hey, Omaha. There's thunder rolling in. Shout out to Omaha. And let me just check the life of the stream here. This has been an extended stream. And thanks everybody who has tuned into the Smash News Network, least busted name and news. Let's get back to it. So some active cells there right at Omaha. And it looks like there may be some additional cells behind those. We'll see if we can get you a track on that. An expected storm path is coming. Lots of lightning here in Europe as well. That's your lightning map from lightningmaps.org. Check it out next time you hear thunder. It could save your bacon. Let's do a forecast model real quick. We're just going to do a forecast model here based on the GFS model for pressure and precipitation over the next 72 hours. That's the main thing we need to show, right? Fantastic. There you go. That's the GFS 72-hour pressure and precipitation forecast. No way. There we go. So that's where we expect things to be to start off your July 4th and over your holiday weekend. Some heavy storms are expected in Minnesota. And some concentrated cells expected to kick up across the country. There's a lot of convective forces. You can see here the pressure is kind of all over the place. You can see low pressure, high pressure, low pressure. And a strong low here over Baffin Bay. Yowzers. That's a powerful low there over northern Canada. That's windy.com, by the way. They got a great free mobile app if you want to check that out. Windy.com. It's splentacular. So here's your U.S. Doppler radar map showing vertical motion of water droplets in the air column. Here's your shortwave radiation map showing clouds and fog at nighttime. It's still dark over half the country. The visible satellite won't do you justice. Some rapid cloud nucleation happening here off the Georgia, South Carolina, and Florida coast. And here is your water vapor map. You can see that sudden cloud formation happening there. Some convective forces and some hot water likely at play in that region. We've got a band of dry, massive air here. This is an effective high pressure system. Clear skies likely over that portion of the country. Here's your recap, U.S. Doppler radar. Shortwave radiation map showing clouds and fog. Very cloudy and foggy over Mexico. And there is the water vapor map. That should clear things up. We hope you're able to forecast your own weather. We hope you enjoyed the space weather and so on. Thanks for tuning into the Smash News Network, least busted name and news. And may that solar wind be at your back.